Hey, grade eights. We are starting chapter uh 10. This is, and we are doing algebra. So this is one of the most important units in what we do this year. There's many important math things, but this is definitely one of the most important, and you will be doing lots of algebra in the rest of your math career, however long that may be, but at least until the end of high school. Um, so we're starting with solving one-step equations. So we did this in grade 7 already, so this actually is, for many of you, hopefully you remember it, and it's review. Just going to make this a little bit thinner here. Actually, I'll do it right. Okay, so one-step equations means that there's just one thing being done. So just multiplication or just division. And so they're in the forms ax is equal to b and x divided by a is equal to b, where a and b are certain numbers. So just to sort of review this, if I have 3x is equal to 12, we're doing this one here. What is this showing us? Well, let's actually draw a little teeter-totter, because the equal sign means that both sides of this teeter-totter are balanced, which means that if there is 3x on one side and there is 12 on the other side, our teeter-totter's balanced. So we have 3 x's. We can show those by making little boxes with x's in them. Okay, there's my 3 x's. And on the other side, I just have 12. So let's make those red. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Now the problem that we're trying to solve is, well, how much is 1x equal to? So, how many of these little red dots would have to be in each of these 3 x boxes for this teeter-totter to be balanced? So what we want to do, if we actually had a teeter-totter balanced, or a weigh scale like this, where we could balance things against each other, we could just remove some of the x's until we have only one x, and then just remove the same amount of the counters on the other side, and then it should remain balanced. So if I was to remove 2 x's, there we go. If I was to remove 2 x's, it wouldn't be balanced if I just removed 2 counters. I would have to remove, since I removed 2/3 of the x's, or I divided the number of x's by 3 to get just 1 x, I will also have to remove 2/3 or divide the number of counters on the other side by 3. Okay? So I took 2/3 away from the left, I took 2/3 away from the right, and now I'm left with x is equal to 4. Does this make sense? Well, we can just use our mental math. 3 times something equals 12. Well, yes, it's 3 times 4 is equal to 12. But we can also show this by balancing out our scale. Okay, so what about x is equal, or x divided by 5 is equal to 4? So I have x divided by 5 on one side. How do I show that? Well, let's show 1x being one long strip this time. And I have just 1/5 of it. I show x divided by 5. I could also write this x divided by 5. It's also the same as 1/5 times by x. Okay, so I have 1/5 of x. So if my x, I only had 1/5 of it, and then I had another 4/5 for just sitting there empty, that is equal to 4. Okay, so this is equal to 4. This strip here, or sorry, this 1/5 of a strip is equal to 4 of the x. Well, how much would one whole x be equal to? Well, if I were to add in another fifth, we know that 1/5 is equal to 4, so 2/5 would be another 4 counters. 1, 2, 3, 4. And then I can add in another fifth, which would be another 1, 2, 3, 4. And really, I'm just having to take that 1/5 and times it by 5 to fill it up. And for each one of those fifths, I'm going to have another 4. So if I have 5 times the amount on the left to equal 1x, I'm going to have 5 times the amount on the right. And then I have 4 here, 8, 12, 16, 20. Okay? And so I'm saying x is equal to 20. Okay? Now I can just double check. Does this make sense if I put it in for x in my equation? Well, 20 divided by 5 is equal to 4. So that must be the answer for what x is equal to. Okay, so we can sort of show our equations using these scales, but what we're really thinking of is that we're just always doing the same thing on both sides of your weigh scale, or both sides of your teeter-totter. Okay, so if you had a teeter-totter that was balanced, and let's say there was 2 x's here, and 6 counters over here. Well, or let's say, there's also 2 counters here or something. If I added on 2 counters on the right side and added on only 1 counter on the left side, it wouldn't be balanced anymore. But as long as I always do the same thing, I could add on 3 counters here and I could add on 3 counters on this side, it stays balanced. Okay? I could take away 2 counters on this side, take away the 2 counters on this side, and it stays balanced. I take away half of the counters on this side, take away half of the counters on that side, it stays balanced. So the biggest thing that we're trying to get to remember is that you always, whatever you do on one side, you have to do on the other side of an equation to keep it balanced. So let's look at a few examples where instead of drawing diagrams, we're just going to do the opposite operation. So here I have 8x is equal to 56. So I have 8 times by x is equal to 56. I want to figure out what just x is and get it alone, all by itself. To do that, I'm going to do the opposite operation. So if I have 8x and I divide 8x by 8, those 8's cancel out because 8 divided by 8 is 1. And so I'm left with just 1x on the left side. I have to keep my teeter-totter balance, so I also have to divide by 8 on the right side. So 56 divided by 8 is equal to 7. And there's my answer. X is equal to 7. One thing that's always important to do is to check your answer and to see if the left side is equal to the right side. So I got x is equal to 7. I'm actually going to substitute that back in for what x is equal to. So 8 times by 7 instead of x. 8 times by 7 is equal to 56. 8 times by 7 is 56. So 56 is equal to 56. Yay, since the left side of my equation is equal to my right side when x equals 7, that means that I found the right answer. Okay, this time I have x divided by 11. Let's just rewrite that. X divided by 11 is equal to 7. So x is being divided by 11. I want to times x by 11. So it's important that you times x by 11. You don't want to times 11 by 11 because then you'd have x over 121. But we want to get rid of that 11 on the bottom of the fraction. So we multiply x by 11. I also multiply the 7 by 11. Since I did the same thing on both sides, teeter-totter stays balanced. 11 divided by 11 is equal to 1, so those cancel out. And I'm left with x on this side, and 7 times 11 is equal to 77. Let's check, does that make sense? If I put 77 in for x, well, 77 divided by 11 is 7. Okay, good, so my answer is correct. Okay, let's do one more. I'm just going to erase this so I have a bit of space. So I have negative 4x is equal to negative 20. So I have some negatives now. Now, some of you might be doing this just looking at it and thinking what the answer is. That's good if you can do this in your head. Just think, oh, well, what times 8 equals 56? Well, 7 times 8 equals 56. Great to do it mentally, but it's very important that you can follow the steps too. So I have negative 4 times by x. So I want to get rid of that negative 4. So I'm going to divide, since x is being multiplied by negative 4, I'm going to divide by negative 4, do the opposite. I also divide by -4 on the other side. -4 divided by -4 is 1. So I have 1x, or just x we can write. We don't need to show that 1. A -20 divided by -4 is equal to negative divided by negative is a positive, so it's positive 5. So x is equal to 5. Okay, so that's great. This I can now put back in and check if that makes sense. -4 times by, instead of x, times by 5, positive 5, that's what I'm saying x is equal to -20. Well, -4 times by -5 is equal to -20 on the left side, and -20 is equal to -20. I checked the left side and right side of my equations are equal to each other once I have found the variable, and they are, so yay. Okay, so we were using some problems that you could solve in your head, but we can follow these same steps and just use a calculator. So you will be able to use a calculator for this whole unit, and you can just follow the same steps, and you should be able to find the answer. So for example, I have 456x, and then that is equal to 18,364. These are just random numbers I put in. But if I want to find just one x, as long as I divide, x is being multiplied by 456, so I divide, do the opposite, divide by 456. Whatever's being done to x, I do the opposite. I also do the same thing on the other side. So I divide by 456 on the other side. 456 cancels out, because 456 divided by 456 is 1. So I'm just left with just 1x. And 18,643, I'll grab my calculator, 18,364 divided by 456 is equal to 40.2719, and it continues. Okay? And then again, I could substitute what I found for x back into my equation and check that I found the right answer. Okay, this one right here, x divided by 83, usually you'll see it in this fraction form, is equal to 0.2. Okay, I can't think in my head necessarily what x might be, but since x is being divided by 83, I'm going to do the opposite and multiply x by 83. Well, 83. Also multiply by 83 on the other side. Keep things balanced. These 83s cancel out, so I'm left with just 1x on the left side, which is what I want, just the 1x. And then on the right side, 0.2 times by 83 is equal to 16.6. Okay, and then I could check. Put 16.6 in for x, so 16.6 divided by 83, what do I get? Oh, I get 0.2, so I got the right answer. Okay, so hopefully you remember some of this from grade 7. You're always just doing whatever's being done to x, you're doing the opposite. So the opposite of multiply is divide. The opposite of divide is multiply. The opposite of add is subtract. The opposite of subtract is add. So you just do the opposite to x of whatever's being done to it and do the same thing on both sides of your equation. Let's get into some word problems. Mike's age is 1/3 of Susie's age. Mike is 13. Okay, so write an equation that could be used to model this situation, then solve for how old Mike is. So let's turn some of this into variables. So Mike is going to be the variable m. Susie is going to be the variable s. So Mike's age, which is m, is equal to 1/3 of Susie's age. Or, you know, we can show that 1/3 Susie's age, or we can show that as Susie's age divided by 3. So Mike's age is equal to Susie's age divided by 3. Okay, that's what this first sentence tells us. The second sentence says Mike is 13. So instead of having this variable m, I can erase the variable m and put in 13, because that's Mike's age. So 13 is equal to Susie's age divided by 3. So now we can solve for how old, it shouldn't say solve for how old Mike is, it should say solve for how old Susie is, because we've been told how old Mike is. Okay, so now I can solve for Susie's age. Susie's age is being divided by 3, so I'm going to multiply by 3. I'm also going to multiply 13 by 3. These cancel out. 13 times 3 is 39. And we're just left with S on the right side. So we see that Susie is 39 years old. Does this make sense? Well, if Mike is 1/3 of Susie's age, it would make sense that Susie would be 3 times older than him, or 39. So yes, that makes sense in this situation. Okay, so I first turned it into the equation. 13 is equal to S over 3, and then you just solve. Let's look at another one. So Bert and Ernie both went for a run on Saturday, but Bert ran 4 times farther than Ernie. Okay, so let's just start with that. We got Bert, which will be B, and we got Ernie, which will be E. So the distance Bert ran was 4 times farther than Ernie, or 4 times the distance Ernie ran. Okay, so it's important to look and think, okay, who ran farther? Well, Bert ran farther. So we're going to have to multiply Ernie's distance to make it equal to Bert's distance. Okay, Bert ran 4 times farther than Ernie, so 4 times what Ernie ran. Bert ran 18 kilometers. The second sentence shows us what we can substitute into this equation, because right now in our equation we have 2 variables, so we can't solve it. But once we say, well, B is actually equal to 18 kilometers, now we're able to solve this. Okay, so Ernie's distance multiplied by 4, so I divide by 4, I divide by 4, 4 divided by 4 cancel out. 18 divided by 4, you could use your calculator. Some of you might know 18 divided by 2 is 9. Divide that by 2 again, it's 4.5. So 4.5 kilometers is equal to Ernie's distance. E is equal to 4.5. Does this make sense? Yes. Ernie didn't run as far as Bert, so he should. 4.5 is a reasonable answer. Okay, so these are some word problems. You might want to refer back to these when you're writing the quiz and just how to write the equations and then solve them. Okay, so if you want to do some other sort of fun practice, I guess, you can go to Solve Me Mobiles, which you might have done in grade 7. So if you just Google Solve Me and then Mobiles, you'll get to this website. You can find this website, and then you click play, and I'm just going to show you some examples of how you can solve them. So the basic idea is you're trying to figure out, well, let's actually just go to a beginning one. Okay, you're trying to figure out, okay, well, these hearts are each equal to 2. Then how much would this trapezoid have to be equal to since this is balanced? Okay, so if I just put in any number here, and I'm going to have to reach over to my computer. So let's say I put in 8. Yeah. Oh, see, I put in 8, and now it becomes unbalanced, showing me that 8 is too large of an answer. But if I put in too small of an answer, like 1, okay, then it goes the other way, and that tells me that that's too small of an answer. But ideally, you'll just find the correct answer. So this whole right side is equal to 6, which means that this whole left side has to be equal to 6. If this heart here is worth 2, then what's left over has to be equal to 4. And so we can put it in, click 4, and it stays balanced, so that's a good sign. And then click submit. Ching! Okay, so that's the overall what we're trying to do. Well, just to show you some maybe new things that you didn't know about what you could do on this website. Something you can do is you can actually, if you click on the little bar, you can grab it and drag it. Oh, I'm going to need to use the mouse. You can click on the bar, grab it and drag it, and then ching, it makes this little equation. So says two triangles is equal to a triangle plus 3 diamonds. So we can actually use this to help solve for what the diamonds are. Now, another neat thing it does is since I have a diamond on the right side, a diamond on the left side, it lets me take away one from each side. So I'm left with just one diamond on the left side, because I had 2 before, I took away 1. And I'm left with, one triangle on the left side, and then only 3 diamonds on the right side. Now, this one doesn't give me a total of what I'm looking for, but it does say that the diamonds are each worth 5. Okay, so if one diamond is worth 5, well, I'm saying the triangle is equal to 3 diamonds, or if it's 5, 3 times by 5. So one triangle is equal to 15. Does this make sense? Well, if this is 15, this is 15. On the left side, it's 30. 5, 10, 15, and then another 15 is 30. So yeah, that would keep it balanced. I can enter in 15 for what one triangle is equal to. Makes it balanced. Hit enter or submit. Okay. So just a neat little thing you can do with these. This is a good website. It doesn't really feel like you're doing algebra, but you actually are. You can drag, again. Okay, so I have a total of 30, which means that on my right side, I'm going to have 15. On my left side, I'm going to have 15. Now, I'm not exactly sure how much each of these triangles and hexagons could be. I could do some guessing and checking. To help me guess and check, though, I could, again, drag this over. Okay, I got a bunch of things, but let's take away one triangle from each side. So I'm left with one triangle on the right side here, none on the left side. I'm going to take away a hexagon from each side. I'm left with 2 hexagons on the left side is equal to 1 triangle. Well, if 2 hexagons equals 1 triangle, that means the amount that a triangle is twice the amount that the hexagon is. So that if 2 hexagons is equal to 1 triangle, that means if my triangle is equal to 10, my hexagon would be equal to half that, because 2 of them equals 10. So it would have to be equal to 5. But this couldn't work, 10, 10, 5, because that adds up to more than 15 on the right side here. So now I can do some guessing and checking, but I know that my triangle is twice as large as my hexagon. So then you can do some guessing and checking. Okay, adding up to 15. Well, could it be 8, 8? No, that's already over 15. Could it be 4, 4, and 2? No, that's not enough. Well, hey, 6, 6, and 3. 6 plus 6 is 12, plus 3 is 15. So I know that that must be the answer. So I can enter that in. 3, 6. Submit. Okay. So you can try some of these with this assignment. It won't always be helpful. It won't always be helpful to do the dragging thing and see the equation, like to do this. Like this, I can't drag anything away here. It doesn't really give me that much info. But sometimes it is. So you can try it and see the equation, and it might help you. Okay, anyways, you'll have an assignment. Do the Google form quiz. Let me know if you have any questions, grade 8s.